warm welcome to all the viewers. Friends, in this video I am going to quickly tell you the difference between variance, standard deviation, covariance and correlation. It's especially important to know the differences and the meanings of these terms if you are a beginner researcher, so that you can choose a wise analysis techniques later on. You must have come across terms like covariance based structural equation modeling, variance based structural equation modeling. CBSEM usually conducted via IBM SPSS AMOS and VBSEM conducted using Smart PLS. Now let us understand what these terms actually mean. So giving you a simple example, I'll start with variance. Variance is the spread of the data points from its mean value. It is always for a single variable. Say we take an example of height of trees. You measured the height of 10 trees and you came to know a certain mean height of those 10 trees. Then for each tree you want to know whether that height is above the mean point or below the mean point. For that you take out the difference between the actual height of that tree and the mean. Okay, so once you get all the differences for each tree, the differences between the observed height and the mean of the series of height of trees. So when you add these numbers, certain trees are going to be above the mean height, certain trees are going to be below the mean height. When you add them up together, you come to a value which is 0. So this does not make sense. Now the remedy for this is that you square up the differences, you add them together, and this summed up squares has to be divided by n minus 1, n standing for sample size, minus 1. In case you are working for entire population, then you just divide by the population size to get the population variance. But here we are talking about sample variance. Population variance is a rare chance when you know the entire population. In that case you divide by capital N, which stands for the population size. I have included all the formulas in the description so that you can use them effectively. Variance is expressed in squared units of the measurement. Say the height was measured in meters, so the variance unit will be meter square. Now to standardize this, we take the under root of the variance value and we get something which is known as standard deviation. Standard deviation is expressed in the real measurement units. So now you again come back to meters when you take out the square root of variance. So that is known as standard deviation, right? Next we talk about covariance. Covariance is done for two variables. It's the relationship between two variables which tells us the direction of the relationship. If one variable increases, the other also increases with it. If one decreases, other also decreases with it. Or if one increases and the other decreases. In case they are having a similar directional relationship, say both increase or both decrease together, we call it positive covariance. In case one increases and the other decreases, we call it negative covariance. Now this is just the direction. It can range from minus infinite to positive infinite depending on the scale of the measurement. Let us take an example. So moving with the previous example, as I already stated, the height of the trees, that was just one variable. Now we are going to study the effect of sunlight, exposure of sunlight on the height of the trees. So now have the second variable, that is sunlight exposure. If I observe that the trees which receive higher amount of sunlight have a higher height and trees which receive lesser amount of sunlight have a lesser height, that means it's a positive correlation. In case it was an unusual phenomena, like one variable increases and other decreases, then we call it negative correlation. When both decrease together, then also it's a positive correlation. So in this case we call it correlation. It is expressed in minus 1 to plus 1. So the value of correlation coefficient, that is R, ranges from minus 1 to plus 1. When you talk about coefficient of determination, it is the squared value of correlation expressed as R square. You must have come across the term R square as well. The correlation value gives you the strength as well as the direction of the relationship, ranging from -1 to +1. 0 means no correlation at all. -1 means perfectly negative correlation. And +1 means perfectly positive correlation. So covariance was just telling you the direction of relationship, but the correlation is telling you the strength as well as the direction of the relationship. We often come across a term which is known as multicollinearity, which is high correlation between the variables. In case the correlation is higher than 0.7, then it is deemed to be highly correlated. It could be plus minus 0.7. I hope this video was quite informative and useful for you. And now you will be able to apply the statistics wisely as desired by your data for the analysis as per your laid down objectives. Thanks a lot.